Okay, let's get started. So, on lesson 4, what did we do? 2 through 22, probably?
34.
All right, look at that. We did all kinds of things. Y'all must be in pre-cal or something. Okay, so here we go. Number 2 is not a real number. Number 4, negative 4/7. Number 6 is 5. Number 8 is negative 4. Number 10 is 2 times the absolute value of a to the 5th. 12 is 3x to the 5th times the cube root of 2x squared. 14 is 11 times the absolute value of z minus 2 in parentheses to the 7th. 16 is negative qr squared times the 7th root of q to the 6th r squared. 18 is 6x to the 1/2 y, or you could write it as 6 times y to the times the square root of x. Either one would be fine. Number 20 is 2 times the 6th root of 2b to the 4th. 22 is the 12th root of 3 to the 5th, all over 3. Number 24 is $8,586.50. Excuse me. 26 is 8, and 28 is 1/3. 30 is negative 5r cubed t squared u times the cube root of 2r squared u squared. 32 is 2a squared times the absolute value of b times c to the 5th, then times the 4th root of 6b squared. 34 is absolute value of c times d times the 4th root of a squared b cubed d. What questions do we have on those?
Got 2 right.
Okay, so.
Okay, I don't have a problem till 12. Do you have one before that? I've got all of them.
We don't have to go in order. What number do we want to look at? 12. Okay. All right, 12. We got the cube root of 54. This is page P something, P17. Number 12. And what did I say? Cube root of 54. The cube root of 54 times x to the 17th. And we are expected to simplify as much as he'll simplify. We have essentially 2 tools in our tool belt to do that. So what might we do?
Separate the 54 and the x to the 17th into 2 separate cube roots.
Sure. That's a fine first step. We might want to start playing with those a little bit. Can we turn 54 into something that's going to give us a cubed in there? Not really, not by itself, right? So okay, so yeah, let's start thinking through the perfect cubes, right? So 1 and 8 and 27. Okay, 27 we can pull out of there. What is that going to be? 20? Like what is it going to be? 27 what? Times 2. Okay, so let's turn this into 27 times 2. In fact, well, no, let's not. In fact, let's slow your roll. Okay, my roll, not y'all's. Y'all are doing great. So we can turn that into the cube root of 27 times 2. All right, what about this one? Can we like do something magical with it?
We do x to the 8 and x to the 9.
Sure. Well, no, we can't do x to the 8. Oh yeah, we can. because
I'm
math.
confused about how exponents work.
No, you're right. You're right. You're 100% right. That is a thing that we could do. I don't know if it's going to help us, but it is a thing that we could do.
Can you split those up into like 4 different things that do the same thing?
Yeah. As long as they all add up to 17. All right, the first bit we can deal without a whole lot of trouble, right? Because this splits into the cube root of 27 times the cube root of 2, right? Which would be 3 times the cube root of 2, right? That one's no big deal. Easy monies, yeah? Now the next one. What now?
I'm not sure how exponents deal with being in the root of something.
Okay, so I'm going to tell you the way that I think is easiest to do this. So there's sort of 2 ways to think about roots and exponents. There's the just straight up division way, kind of jump through hoops in your head and whatever else. But what I think is easier is to think about it as rational exponents, right? So with rational exponents, you've got the root here, right? And then you've got the exponent, and that turns into the numerator of a fractional exponent and the denominator, right? Okay, so we might, in fact, on this one, let's kind of go back. Instead of picking those numbers, let's pick different numbers. Let's put, and it'll make sense when I write it down. So the cube root of x to the 15th times the cube root of x squared, right? Because 15 plus 2 is 17, right? That's where those came from. That makes sense? Okay. So we can think about this one of 2 ways. Is there are 5 cube roots in here. And so it's going to be x to the 5th. That's the kind of like mental gymnastics way of being able to kind of be like, yeah, this is an answer, right? And if that works for you, that's fine. But you can also turn that into x to the 15th divided by 3, right? Because the root is on the bottom of the fraction and the power's in the numerator. And then 15 divided by 3 is easy money, right? That's 5. So this would turn into x to the 5th. And then we just still got the cube root of x squared. Right? Now we need to do one more thing to clean it up. What do we need to do to clean it up?
Put together the powers and the exponents.
That's right. So we end up with 3x to the 5th times the cube root of 2x squared. Now, you notice that this x to the 5th is not an absolute value. Why is it not an absolute value? Because we ended up with an odd exponent.
Because it's a cube.
That's right. Odd to odd. Yep, we went straight from odd to odd. If we went from even to odd, that's when we need the absolute value. What? If we started out with the 4th root of x to the 5th, maybe, right? We could do the 4th root. Oh, this is a bad example because that's going to end up as even. What's something that would end up odd to the 8th? No. 9 minus 4 is 5. That'll work. No, it won't. What's an example of one that does this? Let me do one that ends up in absolute value. Let's just pick one. Let's pick 10. Let's do 10. Because then I don't have to think so hard. Do one that we already know does the thing. All right, so for 10, it's the 4th root of 16a to the 20th. Oh, that would have worked. That first one I said would have worked. Because 1 is odd. That's fine. We'll do this one anyway. Totally fine. All right, so what do we do here? Separate it. At the 4th root of 16 is 8 and 2. Well, 16 is also a perfect 4th, right?
Yeah, it's like 2.
Yeah. Times the 4th root of, let's do this one and do it this way. A to the 24th. over 4. Then that's just easy to think about, yeah? This one turns into 2, and the a ends up being to the 5th. Okay, so this is where this happens. So if we start out with an even root, and we end up with an odd power, we have to put that in absolute value. So we start out even root and end up with odd power. We have to do an odd, because an odd exponent can give you a negative answer, and we can't find a negative even root.
Do we put that back into like the square root thing?
No, because this reduces to just straight up 5. If it was 1/5, then that would be the 5th root.
So the bottom has to be something other than 1 for it to.
Yes, into a root. Yes,
This is confusing, man.
you got this.
Can you answer the 14 then?
14, you said? Okay. Oh, actually, I have things to give to y'all. Hold on, give me a second. There you are. There's Garrett's blue pen. No Garrett name. This time. He'll remember next time.
He's not here for you.
I wagged my finger at it, his virtualness. Okay, 14.
Because the real goes out before the
Yeah.
imaginary.
Yeah.
That's a little stupid.
It's pre-cal, babe. Pre-cal. What? What did you say? Oh, yeah. That's what I was planning. But then there were more words that were involved. Square root of 121 times x minus 7 something.
2.
Sure, whatever. It's going to be almost the same thing.
14.
Yeah, that.
So yeah, the square root of 21, which is 11. We wouldn't want to. And then you.
I think that's easier to think about than trying to split it up and whatever else.
So it's going to be, I only did that because I misunderstood how to do the
Mm-hmm.
over thing. So it's going to be 11 absolute value of parentheses z minus 2 to the 7th.
No.
No.
Yeah, it would be absolute value. Yeah, you're right. Yeah, all the things you just said are right.
Yay, I'm understanding how to do the math.
Good, that's the goal. All right, what other questions for this lesson do we have?
18.
18.
So it's 11 times the absolute value of that thing?
Yeah, of 11 times the absolute value of x minus 2 to the 7th.
The 7 has to be in the absolute value?
Yeah, well, it would technically, mathematically be the same either. Well, no, it wouldn't. Yeah. Yeah, it's got to be in it.
Look how smart that is, bro.
You can do this. You're doing fine. All right. 18. Exponent rules.
I actually got this one right.
Good. You remembered something.
So they remember more than I did. I don't remember myself.
I got 3 right. So I think you're better. 2 and then you just plug in the calculator.
Yeah, that was good. That was nice. Everything else?
No dice.
Yeah, and your cheating calculator.
Computer didn't want to be used for math, then don't make computers out of math.
Right?
Every single computer is just a glorified calculator.
That's sort of true.
That's true enough that my engineer dad doesn't have an aneurysm when I say it, so I
Right, there you go. I'm sure your engineer dad enjoys when you say things like that.
oh yeah, he does. Okay, so do you turn all of these into roots? Initially or no?
Okay, now that I've been obnoxious and just did a thing, let's talk through what it did. So the numbers in the front, the coefficients we just multiplied, right? That's easy money, yes? So we have like bases multiplied. When you have like bases multiplied, what do we do with the exponents?
Add them.
Add them. So 1/4 plus 1/4 is 2/4, which is the same as a half, so square root. And then, actually, should that be an absolute value? No, because we started out with odd roots.
A half is just a square root?
Yeah. Half as an exponent. Because if there's nothing there, it's a square root, right?
Okay, because you know how we do the thing where it's the number above the exponent and then the number in the root. So if you put those, so take it from the fraction.
Because if it was a 3, it'd be a cube root.
It'll be square root of.
Right, and so a 2 would be a square root. That makes sense? Yes. Yes.
How do you get y to the 1?
Because 1/3 plus 2/3 is 1. I mean, if it makes us feel better, we could,
I thought we were doing the.
and then it turns into 1.
Okay, so why don't,
Why don't what?
why do we not foil?
I guess you could argue we did, like we didn't foil, but there's no plus there.
Oh, so that would, I thought it was multiplication.
It is multiplication. You're gonna have like bases multiplied, and you add the exponents.
Oh, like the.
We are multiplying.
Yeah, I'm sorry, the parentheses just confused us all.
Yeah,
It's basically, that's one expression, because there's no.
yeah. It's an unsimplified expression, and then we simplified it.
You just multiply the like bases and you don't distribute everything on each other?
You could argue we kind of did that, but I don't like. It's just all multiplied. There's no pluses, no minuses. It's just all multiplied.
The two things in the parentheses, when they're plus, then
Oh.
you FOIL it.
Like,
There's no
like if it was this,
Yeah, you're right. Yeah, because the exponents are all
Then-
yeah, they're all connected. They're all one thing.
yeah.
So then the answer is just 6y to the square root of x?
Yep, it is.
Sorry, x squared times square root of x.
It is. What other questions from this lesson?
22.
No, 22 is even more fun. Look at that.
Oh, yay. Math, fun.
22, 4 through to 27.
Over the cubed root of 81.
All right. So 2 problems. One, we don't like roots in the denominator. Number 2 is we got to simplify and smoosh stuff together. In order to simplify and smoosh stuff together, we really need bases to be the same. We got a 27, we got an 81. Those are not the same number. So we need to turn them into the same number. So how can we turn them into the same number?
Split it up.
We don't even have to.
You just multiply it by 3 over 1.
So multiplying it by 3 over 1 will change the number. We can do 3 over 3. It's kind of easier than that, and you're thinking right with the 3. The 3 was on the right track, right? So the 3 was a good thought, right? What if we did this? This is the 4th, right? 3 to the 4th is 81. Is my mathing? It's 3 to the something. Yeah, definitely. Okay, great. Okay, now what?
Do you do the 3/4 over 3/4?
The book is not getting what I think we're about to get. Because what happens in the denominator right now?
Maybe just becomes a 3.
Comes a 3.
But the bottom is supposed to be a 3, a cube root.
What are you saying?
The bottom's the cube root.
Oh, that's why. Oh, there we go. Okay. Copy error. That was the issue. There we go. Okay, so now what do we, probably whatever you said, I don't really know. What are we gonna do?
3 to 3/4 over 3 to the 4/5.
Yeah, that's what I would do. I would go ahead and convert to rational exponents at this point. Because I think that's gonna be easier to deal with.
And then
Dividing and the subtracting.
That's right. Like bases divided, you subtract the exponent. So what's 3/4 minus 4/3?
give me a second.
Just punch it.
No, I'm doing the math.
We don't have time. Just punch it. Don't use the tool. That's what your engineering dad does.
I want to make sure I understand what in the world I'm doing.
You're in pre-cal. I bet you know how to subtract fractions. Just saying.
It is negative 7/12.
It is.
So it's 1, right? But does the 3's become a 1 because of...
Is that what y'all got to? Everybody agree? It's definitely negative.
Yeah.
Okay, negative second 12ths.
But the 3
It's
is
turned
become
to
a 1.
1 because it's 3 divided by 3, so it's 1.
It's 3. No, we subtracted the exponents, and so it turns to 3 to the that whatever we got.
But is the dividing not doing anything to the...
No, because this isn't actually 3. It's 3 to the 3/4. This is some decimal, and so is this. Okay, so we're not done because we still got a problem. Because with this, what does the negative exponent do?
It turns it into a root.
That's what the 12ths does. What does the negative do? No, that would be if it was in the root.
These. Absolute value?
It puts it on the bottom of the fraction. It flips it over. Okay, so now we have a problem because we have a root in the denominator. We don't want that. So now we got to get a root out of the denominator. Okay, so I would still deal with this with a rational exponent. I think this one especially is way easier to do with a rational exponent than to try to think through it with a root. Way, way easier. Because to get that root out of the denominator, we got to multiply this times 3 to the 5/12ths over 3 to the 5/12ths. Where did I get that?
Because you're going to add, and then it's going to add up to over 12 over 12, so it's going to be to the 1.
1, yeah, that's right. So we're turning that exponent in the denominator to a 1. 7/12ths plus 5/12ths is 1.
So is the answer just 3 to the 5/12, or is it...
The answer is, so 3 to the 5/12ths over 3, or you could write it, typically once we're done with the rational exponents, typically we like the root form, but that's kind of a little bit, who cares? This answer here and that answer there are probably equally as good. So either one of those would be a completely acceptable answer. Unless the instruction said, write your answer in rational form or something like, or radical form or whatever. Look at all those puzzle pieces.
Okay, 24.
24. And just think, this is theoretically review.
I don't remember doing this.
We definitely didn't do any problems that were this extensive. We did all this concept, but not ones that had this many layers. That's what I said. Y'all remember day 1. That's what I said. Pre-cal is just algebra 2 all over again with a little more depth to it. That's like, that honestly, as far as real math proofs and whatever, That's like all of it. That's
It took 360 pages for somebody to try to prove that 1 + 1 = 2, and they still didn't do it. Math is ridiculous.
yeah. So well, that's why in like core math, like real like base level math, which the closest thing we get to that in high school is in geometry, but we have some things these are undefined terms. This is the base. We don't worry about defining these three things. A point is a point, a line is a line, a plane is a plane, period. And then we build off of that.
And we do.
Okay, 24. Value of a car depreciates or declines over the course of its useful life, all the things. V is the value of the original value. Little v of the car are related by that formula where R is the rate of depreciation per year and N is the number of years. This is exponential decay equation, but you don't necessarily have to remember that to solve the problem. Excuse me. Suppose the current value of a used car is $12,000. What will be the value of the car after 18 months at an annual depreciation rate of 20%? So this is a physics problem. So we're going to solve, it's not a physics problem, but it's basically the way you do it is like I would teach you to do it in a physics class. So step one in a physics problem like this is to write your givens with the units, right? So we have 1, 2, 3, 4 variables. So we're going to list those first. We got big V, and we've got little v, which is not velocity. It would be if this was actually physics. But we've got R, and we've got N. So first thing we're going to do is list the things with the units. So let's see what they're given us. The new value, big V. Let's see. So where are the numbers? Depreciation per year is this. Suppose the current value of a used car is $12,000. So which one of these letters is the $12,000 if it's the current value? I think it's the little v, right? The big V is the new value, and the original value is so the little v is 12,000. In the number of years, what will be the value of the car after 18 months? Okay, so this is tricky, yeah. So 18 months, but what does it tell us about the N variable? Number of years. Yeah, so 1.5 years. Gotta make sure this is important if and when you take physics or chemistry for that matter, any other thing, whatever, make sure your units match what they need to match. So if they don't, convert them. Okay, so what would be the value of the car? So we're looking for big V at a rate of 20%. Before we can math with a percent, we need to change him to 0.2 or 2 or 1/5, either one. Generally, in physics, we like decimals, generally, because often we end up with ugly numbers and we round them using sig figs and all the things. And then it gives us the formula V equals little v times 1 minus R to the N, and then we just plug it and chug it. To the 1.5. So then we just do the math. 0.8 to the 1.5
You know what I didn't
times
do?
12,000.
Write the 1.5 in our exponent initially. That's what messed me up.
Yep, there's a lot of little pieces that you can accidentally miss. All right, what other questions from this lesson? Might be about time to move on to systems. Let's move on to systems. Here we go. 0-5, lesson 5. Everybody's favorite, systems.
I forgot to go back and do the graphing ones.
You won't have any like that on the test, so don't stress hard about it.
When is this test?
When is this mythical test? Well, let me look.
Tuesday.
Is it?
You'll be able to.
Next Tuesday? It was Tuesday.
Let's see
Because we have
if my thing agrees with you. No.
Next Thursday.
No, but then on Wednesday.
Then we what?
The review day, if we do not.
Yeah, that's not going to happen.
This is
You get to review. Yep, Tuesday is correct. Tuesday the 3rd is the test day. That is accurate. We're going to do matrices on Thursday, and then a test all over all of this stuff on Tuesday.
Matrices are the easy part.
Matrices are awesome. Love matrices.
Yeah, they're easy, but they're repetitive and they're boring.
Okay, I would rather math be tedious than hard.
What is even a
If you're taking a test, yeah, but if you want to enjoy your life,
Okay.
So you're going to like matrices when we revisit systems later. You want to know why? Because when we revisit systems later, you're going to use a matrix. We're going to learn how to do it by hand, but then you're going to learn how to do the things that we did, and you're going to stick it in here, and you're going to push RREF enter, and it's going to spit out the answers to the matrix. I mean the system. So at that point, you're going to like matrices. Yeah, that's good. That's good. Okay, so let's see. What do we do? 2 through how many?
26.
All right, that seems reasonable. Look at all those 3x3 systems. How much torture was it?
3 days. Let's in tears in my entire Discord chat being just like, oh yeah, I pray for you.
There you go.
3 by 3.
Did y'all yeah, you said sarcastically probably.
My dad.
Did y'all use Kramer's rule? That's what I would have done on every single one of them. Matrices. Did y'all remember how to do Kramer's rule?
Oh,
You have to do-
keep the thing in the thing.
Determinants.
Oh, I didn't remember that.
No.
You just used elimination
I just suffer.
and cried.
Okay,
Okay, here we go. You ready? Number 2 is 4, 3. Number 4 is 4, -3. Number 6 is 5, 0. Number 8 is -1, 1. 10 is -2, 3. 12 is 1.8, -1.4. Yes, if you wrote it as a fraction, that's totally fine. 4, those again, sorry. Which, all of them or just that 12?
Just 12. So
Just 12. 1.8 and -1.4. 14 is 2, -5. 16 is 5, 2. 18 is 1/3, -1/2. 20 is 1, -4, 4. 22 is -2, 2, 4. 24 is 3, -3, 1. And 26 is 2, -7, 12. All right, what questions do we have on those?
a lot. Can we start with 2?
2 and you said 8? Okay, we'll do 2 and 8.
I'm confused with 2 through 6. I thought we were supposed to just graph them.
Yeah, they have an answer.
Is the answer where it intersects?
Yeah. So for number 2, let's turn the TV off.
should I go back and work 2 through 6?
I don't care. Where's my remote? Did Andy steal my remote and not bring it back? That's probably what happened. Yeah, let's see if I can find the button to just push it. It's got to be here somewhere. Wonder if I turn the Apple TV on, if the TV will turn on. I don't even apparently know how to turn on an Apple TV. Go steal Rochelle's remote. I bet it'll work. Why do you have both remotes? She had both remotes for some reason. I don't know. All right, kids. We'll move the camera and point it at the thing. And then we'll do number 2 the smart way. Y'all probably didn't even think to do it this way. You have a graphing calculator. Aiden already asked how much are we allowed to use it? And I said all the ways.
What's the answer again?
4, 3. So let's graph the thing.
Oh, I forgot you can plug it in.
Minus 5.
How do you do 2?
What?
How do I do another line?
Go back to the f of x thing. I think you can push up on that one. Oh, give me a second, and I'll show you. It'll just take me a second to remember on there. Plus 1. Graph it. Where'd the other thing go? Go back.
Oh, I grabbed the wrong thing.
Oh, because I told it not to.
It's 4, 3.
There it is. There's the answer. 4, 3. Let me see. Sit.
I messed it up.
How do we do that on a math?
Tab. You hit.
Whoa.
You graph the 2 lines and see where they cross. Slope, intercept, all the things. You hit tab and it brings back up the thing, and you can get to the different ones with this.
You hit what?
Tab,
Yeah.
and it brings up the.
So we're looking for the intersect. And
Yeah, and that's it.
And the answer is 4, 3?
The answer's 4, 3. What other questions do we have?
20, but I'm sure.
Oh yeah, 8, and then 20. Sounds accurate.
I like the graphing calculator.
That's good. Tools are good.
I didn't know how to use the tools.
That's part of what we're learning is how to use the tools. That's the upgraded version that's one of the upgrades from Algebra 2 to Pre-Cal. We get better tools and we learn how to use them. It's great. Love it. That's what, I did some computer science stuff in college for a little while, and we learned how to do all the nasty stuff. We learned how to do binary search trees and all this stuff, and beat our heads against the wall and whatever else. And then you learn later that, in industry, if you go write this code yourself, they'll fire you because it takes too long. You just go use the library that somebody already wrote and stick it in there. Great. That happens a lot in school, where you learn the hard way and how to do the things, and you suffer through it, and then somebody's like, yeah, just shove it in your calculator and move on with your life. A good friend of mine, actually Garrett's father, a friend of mine is a mechanical engineer, and I was talking to him one time about that. You learn differential equations and all that stuff. He said, yeah, I solved, in my career as an engineer, I solved one differential equation once. Most of these, and knowing him, he probably did it for fun. But, there it is. All right, so we are supposed to use substitution to solve this system. So what should we do?
You can solve for x in the bottom one.
I agree. I like that plan. So we end up with x equals 1 minus 2y. Now what should we do?
Now we can plug it into the top one.
Plug it in the top one. So 3 times 1 minus 2y minus 5y equals 8. And then we distribute the 3 and end up with 3 minus 6y minus 5y. Okay, great. Any other questions on this problem? We're good here. No? 20.
How the heck do we do these?
Magic.
So you don't have to solve for y at first. You can solve for either one and then just
Facts.
do it the
Yes.
opposite way.
Yeah, that's accurate. Absolutely accurate. Okay, number 20. All right. I'd rather solve it with Kramer's rule, but I guess we'll use elimination. I guess.
Can we do one of those
but we will do that when we get to it, which will be in chapter, what? Let's find out.
Are we gonna be doing this again until that?
In chapter 6, we'll do it then.
So like a lot of ways away.
Yeah, yeah. So, number 20. I better start it over here.
Yeah.
Okay. X plus something, I don't know.
2y.
2z equals 5. 3x plus 2y minus 2z equals -13. 5x.
Negative 13? Yeah.
5x plus 3y minus z equals -11.
There's only one of my issues. I had -13 written as -3.
There you go. That might have been the entire or breakage. Yeah, that's why these are annoying, is because there are so many small mistakes you can make, and then it just like wrecks everything. Especially if you do it this way. Okay, so we got to pick one variable to eliminate. And we kind of want to, and we want to look at like all three equations, because we're going to have to use the same variable on both of the first two elimination steps. So what do y'all want? X, Y, or Z? What? That's the one I wouldn't pick. I would pick either X or Z because they both have a 1 on them, right? So I'd pick one of those two. It's probably going to be a little easier. So which one, X or Z?
X, I guess.
Sure, why not? Doesn't matter. Literally doesn't matter.
Why didn't you just like multiply this by negative?
We can also solve this by using substitution, which bizarrely, every time I've ever seen a system like this solved in like an electronics textbook, they use substitution to show you how to do it, which doesn't make any sense. That's like the clunkiest, ugliest, fractioniest way to do it. But let's keep going with elimination. Did you? With substitution? Yeah. That is a method. It's just a giant pain in the butt. This one is close to the same level of pain, but there, yeah. Here we go. So how about we multiply this? Let's number these equations because it's easier to look at later. Multiply this times -3. So equations, and we're going to eliminate with equations 1 and 2 to start. And
Which one do you pick to eliminate?
which variable? No, it doesn't. But it has to be the same one on both of the two things.
Are we multiplying the top one by -3 or?
Yes. So we'd have -3x minus 6y minus 9z equals -15. And then we'll just rewrite the number 2. 3x plus 2y minus 2z equals -13. And then we eliminate, right? So this one goes away. And then we've got a -4y minus 11z equals -28. If y'all see me make a small mistake, holler right away because we don't want to get this whole board filled up and have to go back to the beginning, right? Okay, so now what should we do?
Do X elimination on 2 and 3.
Okay, so we could. I'm going to do 1 and 3 because then we just multiply this one times -5. But 2 and 3 would also work. As long as it's not the same 2 we picked on the first one, then, whatever. All right, so we're going to not do that. We're going to multiply it times -5. So for 1 and 3, we've got -5x minus 10y minus 15z equals 5. Excuse me, and then just write down the 3, 5x plus 3y minus z equals -11, and then we eliminate. So then we've got -7y minus 16z equals negative 6. How we doing? Haven't made any terrible mistakes yet that y'all have noticed?
25 on the
Which one?
equals, the top one where we multiplied by 5, is the equal supposed to be 25?
Negative 25, yeah.
It is. Good job, go team, which means that is 14. Okay.
Is it not supposed to be negative 25? So multiply the whole thing by negative.
Oh yeah, it is, and I was gonna write that, and then I forgot what I was doing.
It's negative 36.
It's negative 36. Giant pain in the butt. Okay. So now we're gonna do these two. So negative 4y minus 11z equals negative 28. And negative 7y minus 16z equals negative 36. Oh! I must be over 30 because I just bent over to pick up a rag and I grunted like an old man. All right, so which one are you picking, y or z? They're both ugly, so.
I think y is easier.
They're smaller numbers, so, you know. Sure, it's fine. They're both ugly. All right, so let's do 7. I'm going to do 7 and negative 4. You can do it the other way, like negative 7 and positive 4 would also work. So negative 28y minus 77z equals negative something, negative 140 plus, yep, 196. And then 28y plus 64z, is that right?
Yeah.
Equals positive 120 plus 24, 144. Okay. That's going to eliminate. And then negative 13z equals negative 52. Is that 4 probably? Or 3? 4. 4 times 3, yeah, whatever. What is that answer?
I'm sorry, I must have
52 divided by 13 is,
Prediction 4.
that's what I said, 4. Yeah, I already said it. Isn't that 4? And then I wanted you to double check my brain. OMG, Aiden, trying to steal my thunder. All right, now what do we do?
Stick the Z in somewhere.
Yeah, we could shove it in up here somewhere.
Can you do one of the already like eliminated ones? Like on 1 and 3?
Like, what are you talking about? I'm confused. What are you?
The negative 7y.
Yeah, we'll plug it in. Yeah, yes. It'd be useless to plug it into one of these because we'd still have 2 variables.
Oh.
Yep. So, negative 4y minus 11 times 4 equals negative 28. Negative 4y minus 44 equals negative 28. Add 44. Which would equal 16. 16, so y equals negative 2. And then we go back and pick one of these and plug both of those in. We'll plug it into the first one, but you could do whatever. Times negative 2 plus 3 times 4 equals 5. So x minus 4 plus 12 equals 5. X plus 8 equals 5. So x equals negative 3.
Why is y negative 2? It's 16 divided by 4.
Well, because I thought I would do different math today. One. So ordered pair, 1, -4, 4.
Wait,
Wait, what?
no, I got it.
Good. Glad you got it.
Is that a 4? Yeah.
It is a 4.
It used to be a 9 one.
It looked a lot like a 9, so I kind of smooshed it. Okay, let's see. What time is it? Where did I set that remote? Way over here for some reason.
Can we do 10?
Number 10. Are you sure you didn't just make a careless mistake somewhere?
Probably. I got -46 over 13 and 29 over.
So you plugged it in. Give me half a second and we'll do a quick thing because I think I want to give you all a real short quiz. I want to do it. We have 6 minutes, so I want to make it happen. So number 10, you probably should have done 2 times 2y minus y. What am I reading? 2y minus 8 minus y equals -7, and then solve from there. Is that what you did? Because all this equals x. You probably did you solve for y on it and then substitute that in? And yeah, so you did.
I solved for 1.
Yeah, you made your life more difficult. Just do that. Put the one that equals x.
Solve for x first.
Yeah. All right, here's the quiz. Page P22, number 9. You don't have to be done right at 12:30. You can stay late as far as I'm concerned. I doubt that it'll take you too terribly long, but if it does, it's fine. This is the second quiz we've had, yeah?
Were you doing substitution?